Okay, next we're going to be talking about linear equations in two variables. This is still Module 4. And this corresponds to section 3.2 in your ebook. This is linear equations in two variables. And generally we're denoting them with x and y. So remember last time we introduced the rectangular coordinate system, and now we're going to talk about linear equations that involve both the x's and the y's. So the first thing I'm going to do is just give you a definition of a linear equation. In two variables. Okay, it can always be expressed in the form of ax plus by equals c, where our capital letters A, B, and C are numbers or constants, and the letters x and y are variables. And what you're going to find later on is that this is actually one form of a linear equation, and we're going to call this in standard form. And I'll bring that up again later on. So as an example, something like 2x plus 3y equals 6, it's an example of a linear equation. In two variables. Right, where x and y are our variables. Negative 5a plus 2b. Oh, actually, let me just go back to, I can say negative 5x plus 2b, whoops, plus 2y equals 11 is also an example. Is also an example. Okay, so one of the things we can do now is we can check to see whether or not a point is a solution to a linear equation. So remember last time we talked about coordinates. That's an ordered pair. Right? We have a pair of numbers, an x and a y. So now we can check to see if a point is a solution to a linear equation. So remember what we did when we only had one variable, right? We found x, we went back, we solved for x, we checked to see whether or not when we plugged x back in to the equation, we got something equal on both sides of the equal sign. Well, this is the same thing, except now we have something for x and something for y. Okay, so for example, let's check to see if the following points are solutions to the equation 3x minus 2y equals negative 12. Okay, the first one, so let's check for the point 4, 0. Okay, so remember, our first coordinate is our x, our second coordinate is our y, so let's go ahead and check. We're going to take 3 minus 2 times y equals negative 12. So I'm going to put in x, which is 4, y, which is 0, and I'm not sure if it works yet, so I just put a little question mark to see whether or not that's true. So I get 12 minus 0 equals, does it equal negative 12? And that doesn't work, right? Because 12 does not equal negative 12. So the point 0.40 is not a solution. Okay, so that's not a solution. Let's try another point. We'll check. Let's check the point negative 2, 3. All right, so remember our equation was 3x minus 2y equals negative 12. Okay, so again, this is my x and this is my y. So I want to check this is part B. So I want to check to see if this works. So I have 3, and I'm going to plug in my x, minus 2, and I'm going to plug in my y, and I'm going to see if that equals negative 12. So here's my negative x, here's my y. All right, x is negative 2, y is 3, so I get negative 6 minus 6. Does that equal negative 12? And sure enough it does. Negative 12 equals negative 12. So the point 2, 3 is a solution. Okay, let's try another one. Let's check the point 1, and we don't even have to stick with integers, so we have 16 halves. So let's check this one again for 3x, the same equation, right? Equals negative 12. So I'm going to go ahead, and this is my x, this is my y, so I'll say it's 3 times my x minus 2 times my y. Does that equal negative 12? Again, I'm going to plug in my x, which is which is 1, my y, which is 15 halves. So here I get 3 times 1 is 3, minus, the 2's cancel, minus 15. Does that equal negative 12? Well, 3 minus 15 is negative 12, right? And so sure enough, that equals negative 12 as well. So the point 1, 15 halves, is also a solution. So if you notice that now we have an equation with 2 variables, we have more than just one possible solution. Remember when we were just solving for x, we found that x was a specific number. But now we can find infinite number of combinations of x's and y's that are also solutions to the same linear equation. Okay, so let's just keep that in mind. Notice that there can be many solutions to the same linear equation in 2 variables. Right? In fact, there are an infinite. There are an infinite number of solutions. And what we're going to find out in later sections is that they all fall on the same line.